So now we're going to talk about another type of binary ionic compound where the metal part is basically going to be an ion, or the element that forms the metal part of the binary ionic compound can make an ion of different type, or different types of ions carrying different charges. So we're going to see how we go about naming such compounds. All right, so there's a system that is used when it comes to naming certain ions, which is called the stock system. All right, now that system is necessary because there are certain elements that can make more than one type of ion, right? And that is indicated in this table here. For example, iron. All right, iron can form an ion with a +2 charge, but it can also form an ion with a +3 charge. All right. So this begs the question, how do you distinguish between those two, especially when it comes to naming? All right. So before we get to that, I want to illustrate the reason why this is important. Because if you look at the type of compounds formed between these ions and a particular anion, then you'll see that the compounds would have different formulas, right? So for example, if Fe2 plus combines with the sulfide ion, it's going to form this compound, which is known as, well, I won't tell you what the name is, but this is the formula, right? FeS, right? On the other hand, if Fe2 plus, if Fe3 plus combined with the same anion, it will form a compound with this formula, right? So these are two different substances, even though they're made up of the same elements, but by virtue of the fact that they have different compositions, right? That means that these are two different substances. And if they're two different substances, then we need to basically find a way of naming them differently, all right? We cannot just simply say that this is iron sulfide and this is also iron sulfide, because these are two different substances, and therefore we have to somehow make a distinction between them in their names, all right? So the IUPAC, that organization, which I think I spoke to you guys about, they came up with a system known as a stock system in order to basically give different names to different ions formed from the same metallic element. And it's a very simple system. Basically, according to the stock system, the charge on the cation is indicated by a Roman numeral placed in parentheses immediately following the name of that metallic cation, all right? So in the case of an anion, or I should say a cation with a +1 charge, we indicate the charge using Roman numeral 1, and so on for +2, +3, +4, and +5, all right, and so on, all right? So whatever the charge is, we basically indicate that number using Roman numerals within parentheses, all right? And then, of course, the non-metallic part always end with IDE, as always, when it comes to binary ionic compounds, right? So just to give you some examples, copper can exist as an ion with a +1 charge, but it also can exist as a +2 charge ion. So therefore, the name of the ion with the +1 charge is called copper 1 being in Roman numerals in parentheses, and the charge carried by copper 2 plus is indicated in Roman numerals in the name. So the name of that particular ion would be copper 2, where we have parentheses around the Roman numeral 2. And you see basically the rule applied to the different ions indicated here for iron, for lead. Now mercury, let me just mention something about mercury. Mercury is a bit unique because even though we have a +2 charge here, this is known as mercury 1, and you'll notice that there's a subscript 2 here, right? So what this is indicating is that the mercury ion here in this particular case is made up of 2 atoms of mercury, and then that collection of atoms carry a charge of +2 overall, all right? So mercury is a bit unique in that regard when it comes to the formula for the ion, all right? And then we have tin, and there are many others as well, all right? And in fact, the tables that I've provided for you in Canvas gives a comprehensive list of all the ions that are of this type, where you can have different ions of different charges formed from the same element. Okay, so let's go through a couple of examples of compounds of this type, where you have a particular metallic element that can display more than one charge. So we have two compounds here. One is FeCl2 and the other one is FeCl3. That's their formulas, right? Now, obviously, they're different compounds because, again, their compositions are different. And the difference really lies in the fact that there are different charges carried by the ions in each case. So, in terms of the ionic charges, in the case of the first compound, the charge on the iron ion is +2, whereas in the case of the second compound, the charge on the iron ion is +3. All right? So, therefore, these are two different compounds. So, how do we name them? Well, the one with the the one with the charge that is +2, the name of that particular ion is iron 2. And as far as this one here with the +3 charge, that is called iron 3. All right. So therefore, the chloride is still the same in both of them, right, in terms of their names. So therefore, the final name for these two compounds are given right here: iron 2 chloride and iron 3 chloride. All right. And that's basically how we name those compounds. All right. Here's another example. We have two compounds here made up of tin and bromine. And again, they are different compounds because they have different composition. And the different composition arises from the fact that the tin in both cases have different charges. In the case of the first one, the charge on the tin ion is +2. In the case of the second one, the charge on the tin ion is +4. So therefore, in terms of the names of these ions, the name of this particular ion here is tin 2. The name of this ion here is tin 4. Bromide is the same in both cases. So therefore, when we put the names together, the name of the first one will be tin 2 bromide, and the name of the second one will be tin 4 bromide. Right? So that's basically how we name these compounds, where the metal element of the compound can display more than one charge. All right? Now, one more thing I want to say before I move on, and that is that we only use Roman numerals in this situation. If we have ions that are formed from elements and the element can only form one type of ion, then we do not use Roman numerals in those instances because according to IUPAC, that is being redundant, right? So for example, in the case of a compound like NaCl, right? The name of this compound is sodium chloride, right? And according to IUPAC, it will be incorrect for you to say sodium 1 chloride as a name, all right? Because there's only one type of sodium ion, the one with the +1 charge. So therefore, according to IUPAC, it is redundant for you to include the charge in the parentheses beside it, all right? Beside the name of the sodium ion. Okay, so that's basically how we go about naming these compounds. Now, there's another system which I won't get into. I don't think it's necessary for you guys to learn about this. It's called the classical system, right? This is something I definitely won't get into, so you don't need to know about it. Okay, so what I'm going to do here is stop this video here at this stage, and then we're going to move on to discussing naming polyatomic ions, all right?